My name is Michael Radji. I am a principal analyst on the Mandy and Google Cloud Cyber Espionage team, and I am here to present on understanding the ORBs, China Nexus actors, and the coming IOC extinction. So when talking at these kind of deep and varied cybersecurity events, I always like to start from a conceptual framework and kind of meditate on that and come back to it again and again over time. In this case, a poll quote from Samuel Beckett is going to be kind of our jump-off point today. In a landscape of extinction, precision is next to godliness. As the scale and complexity of the China Nexus threat actor problem grows, we have a calling to be more precise in our solutions for this problem, but also in our definitions of the problem itself. Words like network IOCs or botnet or proxy networks are kind of bandied about and are incomplete for encapsulating the true nature of the current state of China Nexus cyber espionage operations. What we did at Mandiant and Google Cloud is instead work through the definition of ORB networks, or operational relay boxes, that encapsulate this problem completely. A quick definition: ORB networks, operational relay box networks, are proxy networks of leased or compromised router and IoT devices that get used like private VPN networks for the purpose of Chinese cyber espionage activity. So in studying these networks, we learned that several factors that we'll discuss today actually eliminated historic defenders' ability to defend only one piece of the Chinese cyber landscape. Gone are the days where you can ask yourself as an enterprise practitioner, what are my priority intelligence requirements? What actor and what are they going to do to me? What can I spend to keep them from doing that? Instead, we now have these wide, broad systems that Chinese entities, governments, have designed to facilitate espionage at scale. So we actually have to defend against a system that is used by multiple actors rather than just one actor that fits within our priority intelligence requirement. So I believe that instead of tracking one actor, we should track ORB networks that are used by multiple actors in a fashion similar to the way we track APT actors. These are the private networks within China that create these compromised router networks used for proxying malicious activity. And these are going to be able to be tracked with TTPs distinctly the same way that APT actors are done. So again, these are private networks of activity by private companies in China. And today, I'm going to display some of the blueprints that they use to facilitate global espionage at scale. So how are we going to do this? I'm going to provide you with two enterprise frameworks that you can take back to your cyber threat intelligence shops or your larger security operations environments to track these networks, as well as to ontologically describe these networks, similar to a MITRE ATT&CK or a cyber kill chain framework, creating a shared, unified framework of how to talk about these things. Because our definitions, if they are not precise, get very muddled very, very quickly, and we're not defending against the same problem. So, just in case you thought I pulled this quote for today, this is my high school yearbook picture, and that is my high school yearbook quote. I love Samuel Beckett. Okay, so really quick, we're going to define what an ORB network is. We're going to cover our first enterprise framework called our Universal ORB Anatomy. That's going to teach us how to talk about these networks. Then we're going to introduce some of the characters: ORB1, ORB2, and ORB3. That might sound familiar. APT1, APT2, these are networks in a China Nexus environment that facilitate proxy networks of compromised routers for espionage, and we are tracking them distinctly. Then I'm going to drill down on a concept we call IOC extinction. This is really the strategic implications of these networks being used at scale. And I'm happy to talk about a couple of complications that it might introduce to our abilities to defend against China Nexus cyber activity. Then our second enterprise framework, ORB hunting in 4 quadrants, basically describing how you can use security technology vendors that you're likely already paying for in your cyber threat intelligence environments in concert with each other to collectively detect these ORB networks in 4 distinct fashions to get some of the diagrams we're going to display today. And then, not to send you guys home hungry, I'm going to demonstrate this framework in action. I'm going to show you the blueprint, and then I'm going to show you how we unmasked one of these actual companies in China creating these ORB networks that they utilize to facilitate cyber espionage operations using our hunting in 4 quadrants method. Okay, so let's start simple. What is an orb network? Simply, these are operational relay box networks. They are a mesh network of compromised routers or leased VPS nodes which relay network traffic to obfuscate source and target destinations. Think about yourself logging into your enterprise environment. First thing you probably do is you log into your VPN. That is a client that exists on your machine. It authenticates to a server, and then it NATs to a different IP address that you can start traversing to a different location. Same concept, except these networks are composed of leased or compromised router devices all over the world. And these are used primarily for malicious activity and China cyber espionage or potential future destructive operations by China Nexus actors. Where do these orb nodes exist? They exist all over the world. They exist in any country that you might want to egress from and pretend you're actually operating in. If you've ever been a malware analyst or even tried to access Netflix in Italy, you understand that you want to simulate being in another country for the purposes of blending into normative internet traffic. Same concept here. They maintain nodes all around the globe, and particularly, it is a competitive advantage for these companies to have a lot of nodes in North America, in Europe, in Mexico, in South Africa. So yeah, they can be anywhere basically. And there are also a lot of nodes that exist within China and Chinese-friendly environments from a policy perspective. And that's largely where your controller nodes are going to be. We're going to talk a lot about controller nodes, but if you're running an orb network, you don't want to host your databases of nodes or your scripts on a random router in Des Moines, Iowa. You want that to be somewhere in a cloud that is not going to be compliant to certain types of requests, should they come in from other governments around the world. Okay, who uses these orb networks? For the purpose of this presentation, China Nexus threat actors. There's always one. I'm looking for you. You're going to stand up and you're going to say, Russia uses ubiquity routers and they have their own orb network. Yes, they do. This particular framework was designed specifically to speak to the China Nexus problem, and I always say it's like a Q-tip. If you read the box for Q-tips, they say you're not supposed to stick it in your ear, but it's the first thing everybody does when you open a box of Q-tips. So this framework is likely applicable to other orb-like infrastructure used by Russian Nexus actors or some crime war actors as well. But for the purposes of today, we're really focused on China, and that was our intention in designing it. Okay, when did they start? Well, orb networks, as we are officially defining them, sometime around 2016. There was a rise of a private industry in China. Basically, around the Strategic Support Force reorganization, we found a greater collaboration with the private sector of companies standing up these networks and facilitating their use for cyber espionage operations. With that being said, there are earlier incarnations of these networks that existed in a semi-private fashion. And we observed around 2016, a lot of these being taken private almost exclusively for exclusive use. And now this has become a very popular trend that has reached maturity by 2024. And as recently as today, the US government released an indictment against one of these companies operating upwards of 160,000 nodes in the United States. This is a problem that we are catching up to. We are aware of this. We've been aware of them for a while. And now it is really a responsibility of the public and private sector to come together to combat these things at scale. 2024, we're talking about an ontology for it. So it gives a little bit of an idea and a contrast to how much we may need to catch up to this particular project. Okay, and then finally, why use an orb network? Most simply, it hides your egress points and your origination points, like our VPNs. It masks us. Additionally, it complicates attribution. It makes it much harder to attribute activity to an individual group. I personally believe that this is an attempt and a byproduct of studying the target-centric nature of cyber defense globally and creating a cost-inducing effort for our defenders. This makes it more expensive to defend against cyber attacks, shifting an advantage towards the attackers. Okay, the next two slides are going to be definition heavy. We're gonna explore these definitions and then we're gonna explore them in action. So we're gonna see these things 3 times. If we don't get it the first time around, don't freak out. It's a text heavy slide and I'm self-conscious about it, so that's why I'm talking through it. We define primarily 2 types of orb networks. These are provision networks and non-provision networks. Provision networks fundamentally are going to be networks that consist of leased VPS routers, devices. These are devices that actors pay for and stand up images on VPS devices for the purpose of proxying traffic through. Non-provisioned networks are going to be networks consisting of compromised SOHO and end-of-life routers. This is what everybody thinks of when you say ORB networks. But in reality, these are complex networks that are going to utilize both leased VPS devices and compromised routers. Fundamentally, you don't want to host all of your scripts on a random router in Des Moines. So it is going to be a concert of devices. Some use exclusively leased VPS devices. Some networks rely very heavily on compromised devices. So high-level view, provisioned networks are going to be leased VPS devices via commercial services that are available to everyone. Providers like Chupa in the US, providers in France that you might be familiar with. Anywhere that they want to appear like they are operating from, they're going to lease a server there and stand up an infrastructure like a free BSD image to start proxying traffic through with their own infrastructure. This also requires actor administration of nodes, meaning if you lease 160,000 nodes around the globe, you're going to have to introduce some level of automation. You're going to have to put certificates for all of those servers with IPs, and you're going to have to stand up images that are capable of running your network, which means automation almost inevitably results in lazy mistakes. That gives us opportunities to signature these networks, detect them at scale, and identify new infrastructure proactively as they're being stood up. So that's provisioned networks. They're paying for them. They're not compromising routers. Non-provisioned routers, these are compromised routers, IoT devices. This is the idea that there is a bakery somewhere in a random state in the United States, and that router might be proxying cyber espionage activity to hit a global enterprise in the government. This requires actor augmentation of network through custom router-based payloads. Malware. Every non-provisioned network is going to have malware that can exploit vulnerabilities, propagate the malware on the particular router, and then usually tunnel through the network or forward proxy traffic through that individual infected node. One caveat that I always want to include is in non-provisioned networks, even though it utilizes malicious compromised routers, you're also going to need leased VPS devices, like I said before, to host your scripts on, and they're also going to be paying usually China or Taiwanese-based cloud providers for the leasing of space and servers for the administration of these networks. Okay, that was the definitions, and I promised at the beginning of this that I would present 2 enterprise frameworks. This is the first of the enterprise frameworks, really intended to establish an ontology or an anatomy, the words that we're going to describe this network with. So I, a human being, have a foot. Elephants have feet, and kangaroos also have feet. The anatomy of those organisms might vary, but the anatomy of a foot describes something universally. We understand it can be walked on, ran on, jumped on. Even though they might be slightly different, the definition remains the same. This framework and each of the different levels of the framework describe all ORB networks. It is universal, regardless of if the network architecture may vary. If it's a kangaroo or an elephant, the same components are going to emerge in each of these networks, and we can use the same words to describe these different components. Why is that important? If you are an analyst in your organization in a government entity or a vendor like Mandiant comes to you and says, I have a malicious IP and they are being used for espionage activity, it's part of an ORB network. Great, we're gonna run it through all of our networks and figure out, did we see it? What is it for? Where is that? Where is that IP? Is it an adversary controlled node? Is it a relay node? Is it a traversal node? So using these words allows us to understand and orient ourselves about what type of activity might be targeting our network and what sort of indicators we have to further pivot on and develop intelligence about. So just to run through this very quickly, apologies for being didactic, it's helpful to walk through each of these individually. Starting at the top, the adversary controlled operations server, the ACOS node. This is the administration node. I said before that these are largely private sector entities, companies, contractors that administer their networks. Think of this as the VPN provider. They are going to utilize these ACOS nodes for the administration, the backend, and the engineering of their ORB networks. Once you authenticate to your particular proxy network, think of yourselves logging on in the morning, you're then going to have an instance where both the users of the network, you and your enterprise, or in the case of orb networks, APT actors, are going to be using relay nodes to authenticate to their networks. So both the administrators and the APTs that are paying for the use of these services are going to authenticate at the relay node level. Both ACOS nodes and relay nodes are largely behind the Great Firewall as a repetitive tactic. Just like I said before, it allows more control for these particular entities operating within China. And then after you authenticate to the network, that's when you really start to move. That's when the concept of orb networks kicks in. We are traversing through our orb network, hopping from point to point. And that could be leased VPS devices, provisioned networks, or compromised routers, non-provisioned networks. And this is largely the 126,000 nodes that were taken down today in the US government disclosure. That's the traversal pool that's being attacked. And then finally, we have the exit node, which is the point at which you exit an orb network, and then everybody here in this audience, the victim server, the final location, your enterprise, your publicly exposed network devices. This is the attack surface that we all have to manage and all need to make risk decisions about. Okay, we covered a lot. I talked about Nelly, feet. Now let's talk about some of the characters in our story and get a little more relatable in what we're talking about up here. I want to introduce Orb 1, Orb 2, and Orb 3. The first orbs that Mandiant tracks similar to the way that we track APTs with TTPs individually progressing over time. The first of which, Orb 1, is also known as Orb Weaver. This is a non-provisioned network, so think compromised devices within our network, and it's known for having payloads that are responsible for augmenting this network, Gobrat and Whipweave. Some of those have been talked about publicly. Gobrat, JP Cert did an incredible piece on it. Whipweave is an internal malware name utilized by Mandiant. An interesting miscellaneous fact about these two networks is despite having completely different malware frameworks, they are interoperable, meaning nodes that exist within the Gobrat network and the Whipweave network can communicate with each other and relay each other's traffic, suggesting that there is a complex business relationship between the developers of this particular network over time. And on the right is a image of, on the top, the Whipweave network, and on the bottom, the Gobrat network. And the reason I show you guys this in depth is think about our universal orb anatomy. You see the APT icon, which is our ACOS node. You see in the Huawei Cloud's Alibaba icon, you see that as our relay node. You see a big traversal pool of all of the different nodes that they can communicate with. And then you see a staging and exit node before going to the public internet or possibly victim enterprise environments. So it is a universal anatomy that sufficiently applies to the Whipweave and Gobrat network. To provide an idea of scale, we were tracking this, and in the last couple of months, I think we saw something like 410,000 nodes that are deployed globally. That is from our visibility, which is very limited. So just to give you guys an idea of the scope that is happening on an international level. Moving on to Orb 2. This is my personal favorite, one that I put a lot of work into. It is one of the more baroque orb networks that we track. This is our elephant. Basically, it's a non-provisioned network. There are compromised routers, but within this orb network exists an entire Tor network. So these guys are doing some pretty sophisticated things to proxy their traffic from an ACOS node into the Tor network, down into another relay authentication node, over to a stager node, and then into your traversal pool. Trying to orient yourself through that is very confusing. But we now have words that describe the different levels that we are at any time in that network. And to add one further wrinkle to this, there's nothing that guarantees operators traverse these networks in the same order every time. They have the ability to select nodes to tunnel through. So these words become ever more important when we are trying to navigate through them. One thing that I will note is we associate the payloads Flower Water, Petal Tower, Zorat, Mud Mirror, Shimmerpick, others as well, that I'll talk about in a little bit. This is the network that we're going to unmask later on. Right now they are FloraHawks, but by the end, we'll know specifically what company is behind the FloraHawks network. Okay, and the last one. This is our Plain Jane network. This is our provisioned network. It is leased VPS devices that consist of custom versions of a GitHub C2 framework to administer the relay panels that are traversed kind of top to bottom, almost one-to-one with our universal orb anatomy. It is very flat and rather uncomplex, but this is being used by APT-15. This has historically been used by APT-5. We see actors egressing from these networks, and we are able to make educated guesses about what shared provisioning infrastructure, and well, I've said enough. We're in public. I'm gonna dial it back. Okay, so we've talked about our first framework, we talked about definitions, and now we've met some of our characters. I find that it's helpful now to pivot into our strategic overview of this. Why does this matter to risk-making individuals in a cyber threat intelligence or enterprise environment? I believe that boils down to a concept of IOC extinction and the particulars that change because these orb networks are now being used in the wild. So, our defense paradigms for enterprises have been fundamentally changed because of this. Orb networks undermine the concept of actor-controlled infrastructure. When the APT-1 report was written, an actor registered a domain. They controlled an IP. We were able to block that domain. We were able to block that IP. No longer are the actors registering these infrastructure pieces. They're actually not even setting it up. It's being administered by a private company, and they are offshoring within the national boundaries the implementation and the maintenance of these networks, which complicates the way that we operate. It means that we need to be much more aware of how China is doing things today versus how China was doing things yesterday. Our analysts are getting SANS CTI certifications, which are absolutely incredible, written by incredible people like Rob Lee and other individuals that were working primarily before orb networks became the fundamental paradigm. And I know Dragos is doing incredible work on this stuff right now as well. We have a responsibility as an industry to communicate this, as well as update our paradigms and the methodologies analytically that we are using for conclusions around attribution and network enterprise defense. In addition to this problem of actor-controlled infrastructure, we have IOC extinction. The idea that a network infrastructure piece is not going to remain very valuable for very long. This is something that we all know. Indicators age out, but this particular usage of these proxy networks accelerates the aging out of indicators. These companies are competitive with one another. They try to cycle 20 to 30% of their infrastructure within 90 days as a competitive advantage. So what we are tracking and blocking today within 1 month, 2 months, 3 months are not going to be applicable or useful. So having a real responsible plan for aging out of these indicators, how are you treating suspected routers that might be hybrid use, legitimate, and malicious China cyber espionage activity within your SOC environments is a really important question that I don't have a perfect clean answer for. But collectively, as a security community, I think we can shift and adopt a more current paradigm of how this is being referred to today. And then finally, attribution becomes more complicated. We cannot rely on infrastructure alone for attribution. So historically, you saw an IP that appeared in, let's say, a vulnerability exploitation against an RDP device. It was used in May 2024. You see that same IP recur in August, but they're exploiting a completely different vulnerability in a completely different appliance with a completely different set of TTPs. Previously, same IP. Those are the same actors. Let's just go ahead and attribute those. Now, we know that 2 actors around the globe might be paying one orb provider for access to the same orb network. It's unlikely, but we can't say with analytical certainty that those are 2 different actors using the same orb network anymore. So we have different emerging concepts that we need to keep in mind to be analytically accurate when analyzing China Nexus threat actors. The defender's dilemma. We now need to think about temporality, multiplicity, and ephemerality. These are fancy words for when and what infrastructure was part of my orb network. When did I see this IP as part of Space Hop? If that IP is not part of Space Hop based on the services or the certificates or the traffic that I'm seeing in it, I can't attribute that to a Chinese orb network. A multiplicity of adversaries. That's the 2 actors doing 2 different campaigns with different tactics. We now need to assume that there are a multiplicity of actors utilizing this infrastructure at any given time. That's going to be more common if we're observing traffic at relay nodes, or nodes that are choke points in networks, rather than random egress nodes. But it's important to keep in mind, if I'm looking at this IP and I see reuse in a totally different thing that's not associated with one of my priority intelligence requirements, maybe I need to look twice and ask, is that a different threat actor? And then finally, ephemerality. How long is that indicator in my block list actually part of my APT detection for China Nexus threat activity? These ORB administrators are changing. They are updating their tooling the same way that APTs are updating their tooling, and their tactics are going to evolve over time. One further wrinkle, we've noticed APT actors cycling ORB networks, saying, I'm gonna have 3 ORB networks that are completely different. It's not like one APT just buys one ORB network. It's like if you have a corporate VPN and you want to be a malware analyst and analyze things using ExpressVPN and another VPN that allows you to pretend you're in Turkey, you can buy 3 VPNs and nobody's going to say anything. So keep these in mind, particularly about the current paradigms in China Nexus activity that might change the way that we did it yesterday compared to what we need to do today. Okay. That is the laser pointer. Okay. So we've come through strategic concepts, and now we're going to present the second enterprise framework and really accelerate on through the finish. This is our more technical section that deals with kind of in the weeds services that might be used in CTI enterprises that you guys are familiar with. You might not be familiar with it, but the most applicable part is the way that we're deploying these concepts. And I'll circle back again and again to how these concepts are allowing us to make these conclusions as we're moving through. So, Mandy and Google Cloud developed a 4-quadrant detection approach for ORB networks. We utilize NetFlow activity, a study of ports and services available through internet scanning data. We utilize device payload information, which is simple as Yara signatures, which can be deployed in VirusTotal or GTI in the future. And then we study the certificate and response body data occurring in association with particular servers. And these are enterprise services that you guys are going to likely have within your environment. You might have a native NetFlow source, or there's a common security vendor that provides NetFlow. Ports and services are available through a lot of familiar services, things like Census that you guys might be using in your regular security operations. I would hope that everyone here has a VirusTotal subscription. If not, we can take care of that, I promise. And utilizing Yara to particularly hunt for the ELF binaries that are going to be deployed on the router devices in non-provisioned networks. And then finally, certificate and response body data that's also going to be available through an active internet scanning tool or a Census-like service. So these are going to be, when deployed in concert with each other, a very effective viewpoint to give you an ideal image of what an ORB network looks like. And if you translate those prettier images and diagrams that I showed you earlier to signatures, this is what we would be looking like. This is how we gain our understanding of how ORB networks fit together. And keeping an eye on these 4 quadrants is going to be really important to the next case study that I show, in which we unmask FloraHawks, ORB2, the second ORB network, which was the really complicated Baroque Tor network that we looked at earlier in our presentation. So, utilizing some pivots with common tools that I talked about, and a little bit of cyber paleontology to samples from the past, we're going to show a really interesting deep dive into ORB administrators deploying these networks, starting in a very technical signature space and ending up in the actual real world. Okay, what I said, keep in mind these symbols at the bottom left corner. They're going to tell you guys exactly where in our framework we are identifying this particular threat actor activity through pivots. It's going to get a little technical, but bear with me. I'm sure you guys have dealt with this stuff in the past. Starting with a very heuristic signature for a HTTPS certificate, and a TLS certificate. This particular detection occurred based on the subject field within our certificate subject. Danny Adamitz at Lumen Labs wrote an incredible piece about a router-based payload called ZORAT. ZORAT is an English translation for the Chinese word left, referring to a left-hand walk that he observed in the certificates of every piece of malware infecting these particular router devices. If you look at our subject field here, DEFASD, if you use a QWERTY keyboard, DEFASD. It's a left-hand walk, therefore ZORAT. We understand that this is a heuristic detection utilized by shared provisioners of certificate infrastructure within China Nexus provisioning enterprises. It's a good low confidence signature in our environments. What we see based on this is that it hits on an IP and a given port, 8083. Okay, cool. This seems like something in the ballpark of an orb network. Maybe we pull some data on it and see if we can learn a little bit more about that. So now we pivot to our NetFlow section. So we pulled NetFlow on the IP that we observed as part of our certificate here. And what we observed was upstream communication over port 3306, a MySQL database. We understand this to be part of our diagram associated with the FloraHawk's network infrastructure. They have a MySQL database that hosts their backend node list that they're going to be communicating with a really complicated cipher called a Kademlia cipher. It's not important. Anyways, this looks like our guy. We also identified upstream communication with other traversal nodes, a MikroTik router or an IoT Unify camera, and then 2 D-Link ASIS routers that were vulnerable to common vulnerabilities that we've seen the FloraHawk's network exploiting in the past. This looks like our guy. This looks like potentially FloraHawk's, and specifically, this looks like a staging node, the node that's gonna be right before it goes out to a victim environment, because it's communicating back up to the traversal node, and it's communicating all the way back up to our ACOS node that exists within the China cloud space. This is promising. Okay, let's now look at ports and services and see what we looked at. Going back to our first indicator, 8083 was the port that we were looking at. We used our virus total instance to identify same IP, port 8084. It's right next to it. Seems probable that it's it. Interestingly, it deploys a shell script. That particular shell script eventually became the staging script ShimmerPick, which now is identified in your virus total platform. ShimmerPick is interesting. It's super lightweight bash shell script that drops a payload onto the router, particularly a payload called Pedal Tower. That is a tunneler. Basically, that's the captain's wheel to kind of navigate your way through this orb network. It is a tool that allows you to tunnel through all the compromised nodes. It's not the thing that compromises the nodes themselves. Again, promising. So what did we do? When you find a good sample, you usually write a Yara signature, and you deploy that Yara signature in your enterprise environment or in your virus total instance to hunt for more samples. Studying this particular Pedal Tower sample found shared strings, particularly a logging mechanism that was in common between Pedal Tower, Zorat, Mud Mirror, and Flower Water. Those are all payloads associated with our FloraHawk's network. Okay, that's a really good signature. Let's write it up and let it run and see what it finds. In letting it run, we identified a historic hit, something from 2019. Interestingly, it had 80% similarity with Pedal Tower. But the thing that it didn't replicate was the Tor network that was at the center of that giant orb network. 2019 is a long time ago. It seems like they might have been developing this for at least 5 years, and over time, somebody had a pretty crazy cool idea. What if we put Tor network at the heart of it? And in order to navigate that, we might need a new updated tunneling payload to navigate through our network. Pedal Tower and Mud Mirror. Okay, cool. Now we have Mud Mirror, we have a sample. Let's look at this particular sample and see if it relates to any other samples. We identified, again, a tiny bash shell script, which dropped it, that we came to call PlasmaPin. This shared a C2 IP, and interestingly, had commonalities with our ShimmerPick. It also had a really interesting string in the virus total upload field. Shen Zhao Wang Yun. I'm not a linguist. I don't speak Mandarin. Do not ask me. It will go poorly. But I know enough as an analyst to say that appears to be an anglicization of a Chinese phrase. So let's pivot on that. Let's throw that into Google. In putting that into Google, what we found was there were shell scripts associated with 2 blogs, one written by Nacho San-Million and Tezer on the Hidden Wasp ELF payload associated with cyber espionage activity, according to Nacho, and then the Mustic botnet, a piece written by Lacework Labs in 2019 and 2020, respectively. So it was a botnet being utilized for crypto miners, primarily Chinese language crypto miners. What these appear to be, in 2019 and 2020, our first fragments of orb networks being detected in the wild by cybersecurity vendors. And in common, these shells had Shenzhou Wangyun as upload paths. let's take this out of the cyberspace and let's see how close to the real world we can get with this content. I brought on some linguists, because I told you I'm not a linguist. So I brought on some people who were within our organization. And we sent them looking at public records associated with incorporation filings within China. And we identified a corporate entity and specifically 2 regional entities tied to the Shenzhou Wangyun Information Technology Co. Ltd. There is one based in Beijing and one based in Jiangsu. We're all business people. And later on at the Nelly concert, I imagine some of us might have something to drink and say too much about ourselves. These have about me pages. And the amounts that they chose to say about themselves are less than I hope to say about myself later on tonight. They chose to include in their particular about me pages their work for the military industry, particularly the Chinese People's Liberation Army. They also mentioned that they have an intelligence classification standard collaboration with the Ministry of Public Security. And they also said that they are certified by the Beijing State Security Bureau, the MSS, PLA, MSS, MPS, the 3 primary sponsors of cyber espionage activity, and more particularly, in some instances, the organizations associated with the APT actors, we see egressing from our particular engagements associated with ORB network IPs. So, what did we do today? Other than Nelly and feet. We talked about an enterprise framework and an ontology to describe these things universally, so we're all solving the same problem. We talked about our strategic level problems and what this accelerates in our need to shift our enterprise defense paradigms. We talked about how to do this technically and what we can do with our existing tools to get an idea about these networks. And we talked about how to start with a simple detection and take it all the way into the real world to identify the actual entities in another country propagating these ORB networks and administering them. And we did this all, like Samuel Beckett said, by being precise. And with that, I think we got 7 minutes or so for questions. If you guys have anything you want to talk about, happy to answer it. I think we got one right down here.
I'm coming.
Hi, for the ORB networks, are we seeing any threat actors that aren't associated with the Chinese government or military utilizing the Chinese ORB networks, like hacktivists or?
No. So I have not seen instances in which identified APT actors using the Mandiant nomenclature are utilizing these ORB networks. The activity that we have observed, we've been able to correlate activity to specific unclusters and specific APTs. For instance, we've had luck with like APT15, APT5, some of the what we call UNC3236 associated with the Volt Typhoon actor. We have an idea of some of the networks that they might be utilizing. We have not seen cross-national usage of these ORB networks in the China sphere, but that goes back to the Q-tip analogy at the beginning, where there will be implementations of these, and I imagine there will be a company eventually that will open their doors to whoever has enough money to pay for it. But we're largely seeing these exist within a semi-closed ecosystem for acquisition to a set number of people, is how I would describe that. Any other questions? Oh, we got one right down here.
So you're mentioning there was provision and unprovisioned when it comes to those ORB networks. As far as provision goes, correct me if I'm wrong, but it was basically whenever routers or systems were basically infected from users that weren't really aware of it, correct?
So that would be non-provisioned.
Non-provisioned.
Non-provisioned is like your end-of-life router that some small business has. It's vulnerable into the open internet. Somebody will deploy a flower water payload to it, and then it's spreading further payloads or proxying malicious traffic through it.
Gotcha. So then from that, was there a commonality that you saw of those systems that were infected? Were they pretty consistently like specific router, specific product that they were leveraging? And I don't know if it was a 0-day or something that they got for infecting those?
I wish it was a 0-day. The state of SOHO router security is very, very difficult to secure. Thinking of a common person like my mother, my aunt, my grandmother that might purchase a router to access the internet, they are not going to change the default passwords. They're not going to reboot the thing unless they absolutely have to, and they're not going to do firmware updates on those routers, making them by definition vulnerable. When very common CVEs are publicized to the open internet, there is no mechanism by private industry at large to update those routers in a systematic fashion, meaning there's a lot of open doors just dangling off of the internet waiting to be recruited. So commonalities in those networks, it really depends on what the actor has chosen to weaponize. We see them working through common sets of vulnerabilities that might exist in particular brands of routers, and then we'll also see them using different architectures like MIPS or ARM64, ARM32 architectures that allow them to target different breeds of routers vulnerable to the same CVE exploit. So this is largely mass scanning for particularly vulnerable routers, the reuse of default credentials to get them in the network, or using end-day vulnerabilities that have been known for a very, very long time. And part of the attraction of using these devices is they've been unpatched for such a long time, and they remain dangling.
Awesome, thank you.
Yeah, sure. Yep, we got one.
How many orb networks do you guys track?
Nope. See me after. I see you guys. All right, I'm gonna get off stage. Thank you guys, I appreciate it.